Hello, hi, good morning, everyone. So, in the last class, we did few questions on the basis of trace also, and multiplication of two matrices, multiplication of a matrix by a scalar, addition, subtraction. These kind of questions we have already done, and I hope you have seen the video again just to revise. And whatever we have done, that is clear to everyone, that I am hoping. All right, so today we'll do it in continuation only, and the question today I'm going to start is, that is your JEE mains question only, that has been already reflected in the JEE mains. So that question I'll do today, and that is important question, and that is easy question. JEE mains doesn't mean that it is a very difficult question, we'll not be able to do. Of course we can do, but before that we have to do so much of practice, of course. All right. So one question I am taking, that question is, matrix A is also given, matrix B is also given, matrix C is also given to us. That is there in your materials also. Question I am taking now today. First question of the day is, if matrix A is given to us as 2141, 2141, matrix B is given to us as, I know few people have already done this kind of question, 3 4 2 3, and C is 3 minus 4, 3 minus 4 minus 2 comma, no, sorry, not comma, minus 2 3. All right, these three matrices are given to you. Now we have to find the value of trace of A. This is JEE mains question. Find the value of trace of A plus trace of ABC by 2 plus trace of A BC whole square, okay, by 4 plus trace of A BC whole cube divided by 8, and up to so on till infinity. Now how we'll get to know, or how we'll get the idea that what we have to do? See, he has already mentioned in the question itself. From there only we'll get the idea. He is talking about trace of A, where BC is not there. Then he is talking about BC. Then he is talking about BC square. He has separately mentioned in the brackets only. He is giving you idea from there also. So what we'll do? Okay, that idea we'll take now. We'll find the value of BC first. Not value, we say we'll find a matrix BC first. And BC matrix is possible because this order is 2 cross 2. This order is also 2 cross 2. And or multiplication is possible from here. All right, we'll do. So BC 3 4 2 3. And C matrix is 3 minus 4 minus 2 comma 3. And I hope you have read the properties of trace also, but 1-2 properties which I'll use in this question, no, that I'll write it that time also. But after going, or after the class, you should revise, you should read the properties. All right, so if I'll multiply these two matrices, what it will come? 3 3s are 9, and that day I said now little we'll do the calculations now in the brains itself. 3 3s are 9, 4 into minus 2 is minus 8. Now first row will be multiplied with the second column. 3 fours are 12 plus 4 threes are 12. Here was a minus sign, so that's why minus 12 came. Now second row will be multiplied with first row, second row will be multiplied with second column. I said no. Second row will be multiplied with first column, second row will be multiplied with second column. So 3 to the 6, 3 minus 2 are minus 6, 4 2s are minus 8, plus 3 3s are 9. So can you all see it is coming out to be 9 minus 8 is 1, 12 minus 12 is 0, 6 minus 6 is 0, 9 minus 8 is 1, and this is nothing but identity matrix. Alright. So what we do here now, BC is identity matrix. That means identity square is also identity, identity cube is also identity, identity nth power is also identity. And any matrix, if I'll multiply with identity matrix, I'll get the original matrix only. Okay, this is the properties which we are going to use here. And one more property related to trace of A is when trace of k times of A is there. K is any scalar. Here scalars are 1 by 2, 1 by 4, 1 by 8, 1 by up to so on. And I hope you know the formula of sum to n terms also and sum to infinity. Okay, infinity sum in GP, geometric progression, when ratio is same. Okay, arithmetic progression is when the difference is same, geometric progression is when the ratio is same. Alright, so these we'll do it in the questions. Side by side, I'm just revising the concept. Alright. Sometimes, you know, steps are not that much longer. Our explanation is more than the steps. But of course, to keep you engaged, I have to speak this much. But the steps are not there this much. Alright. So trace of Ka, where K is any scalar and K will come out. This is the property of trace of any matrix. Alright. So I'll apply these formulas or these properties or these things which we are already knowing. So I'll apply. Now trace of A. This is nothing but identity. A into identity is A only. So it will come out to be trace of A by 2. This will come out to be identity again, trace of A by 4. Up. Trace of A by 8 and up to so on till infinity. Now these are the scalars. 1 by 2 is a scalar, 1 by 4 is a scalar, 1 by 8 is a scalar, and it will come in front. So trace of A plus 1 by 2 of trace of A. This step is, I am writing it extra just when you will see it later on, so that you don't have to use this much brain that from where this step came. I know you will be able to do, but still one step, instead of saying, I am just writing so that when you will just have a quick revision, no? So it will be easy for you. You don't have to apply this much brain from where and how this step came. So these are the things which I have already used. And now trace of A, if I'll take common, what will be there? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and this is nothing but a GP in infinite terms are there, and infinite sum to infinity formula is what? A upon 1 minus R, where A is the first term and R is nothing but the ratio or common ratio, I would say. So first term is nothing but what? First term is 1 and ratio is 1 by 2. So this is 1 and 1 minus 1 by 2. So what it will come here now? Of course, trace of A is already there, that I'll find. So what it will come? 1 upon 1 by 2, and this will come out to be 2. Now this full term has come out to be twice of trace of A. Okay, these are the steps which we have used. Now find the value of trace of A. Trace of A. How we'll find the trace of A? Add the diagonal elements. 2 plus 1 is nothing but 3. So apply it here. 2 into 3 is nothing but 6. So the option which is getting matched with this is A option. Note it quickly. This was the JEE Mains ka question. In some year it was flashed, it was reflected, and I hope this concept is clear to you. So what I have done in this question, first I found the product of B and C. I got one matrix, and that matrix was coming out to be identity. Identity raised by anything will remain identity only. This was the first concept. Then second concept I used was any matrix multiplied with identity only, I'll get the original matrix only. This concept done. Now third property which I used third thing which I used is trace of k times of A. K times means scalar multiplication of any matrix by a k. So it is nothing but k will come in front, and it is k multiplied by trace of A, and trace is nothing but sum of diagonal elements. So I applied this formula, and it was coming out to be GP. GP means geometric progression. Geometric progression means ratio was same. Ratio, how we find ratio? Second term divided by first term. Third term divided by second term. That means next term divided by previous term. So we got this as this full term was coming out to be 2. 2 into trace of A. Trace of A when we found 2 plus 1 is nothing but 3. 2 into 3 is 6. So I hope this part is clear to everyone. Now next question we are going to do, again that is based on trace only, and that is also very interesting question. I hope you know permutations and combinations. You must have done in your 11th class, and in your previous classes you must have already done. So that is very interesting one. I just love permutations and combinations, because in permutations and combinations we have to use the concepts like relation between the previous step and the next step, and we have to use the concept, no? So those things are interesting actually. These things are also okay, but see, steps are there. Algebra is easy. I find it easy. Okay, bye. Depends upon everyone. Like everyone has their own interest, everyone has their own ideologies, so no problem. Shall I move to the next question now? Next question. Next question is, if A is a 3 cross 3 matrix whose elements are from, if A is a 3 cross 3 matrix whose elements are from the set -1, 0 and 1. Okay, now we have to find the number of matrices A such that find the number of matrices A. How many matrices will be there of such kind such that condition what they have kept as trace of A transpose is nothing but 3. I'll tell you the meaning of transpose here. All right, and trace we already know. What does trace mean? And trace is nothing but sum of all diagonals element. Sum of all diagonal elements. All right, diagonal elements. Now, what do you mean by transpose? Suppose any matrix is there. I am not talking about this matrix. I am talking about any matrix. Suppose any matrix is there. A, B, C, D, E, F, G, H, I. All right. Now transpose. Either so I can apply this thing, or I can write A raised to power T. A dash or A raised to power T. Both are the representations. So now A transpose is nothing but, first I'm telling you the meaning of transpose. Transpose means whatever the row is there, that will become the column. First row will change to first column. All right, and second row will become second column. That means transpose is nothing but interchanging, or row will become respective column. One row is there, that will become first column. Second row will become second column. Third row will become third column. So it will become a respective column. So this is third row, GHI. So that will become third column. All right. Now one thing I am going to see over here, one property is there in A of A transpose that you have to use as a result anywhere you can use. Okay, what is that result now? A transpose. Now what I am doing is I am multiplying this matrix with this matrix. Now see, one magic is there. Which magic? See, if we multiply two matrices, what does it mean? First row will be multiplying with all the first column elements. Okay, so A into A is A square, B into B is B square, C into C is C square. This is my first element of A transpose. Now second element, how it will come? A will be multiplying with D, B will be multiplying with E, C will be multiplying with F. That means first row is getting multiplied with second column. Now first row will be multiplied with third column. So AG, BH, CI. Okay. Now look here now. Now what will happen? Second row will be multiplying with first column, second column and third column. So what it will become? DA plus EB plus FC. This will become second row, second column. So D into D, D square, E into E, E square, F into F, F square. So what magic is happening here that I'll tell you. See, the diagonal elements will come out to be what? Diagonal elements will come out to be Aij's whole square every time. Okay, only in the case of only in the case of A transpose. Second row, third column, so that is nothing but DG plus EH plus FI. All right, now third row will be multiplying with first column GA, HB, IC. This concept I did not tell you prior, that's why I'm using this concept. Otherwise you don't have to show it. Okay, you just have to simply move. But you just have to simply move, like you will use the result that A transpose trace. That I'll tell you. Wait. So now GD HEIF, now G square plus H square plus I square. Okay. Now see, trace of A transpose. What does trace means? Sum of diagonal elements. Sum of diagonal elements is coming out to be nothing but AII whole square, you can say, or you can say AIJ's whole square, where sigma will also come here. Sigma means summation. Okay, I will go from 1 to n, j will also go from 1 to. Okay, so that we'll see now. Just I'm writing sigma not to confuse you people. So sigmas I am writing right now. Sigma over j also, sigma over I also. So it is nothing but its whole square. Every time it will happen in A transpose only, and that too in the trace case. So this is just the result. This you don't have to show it. Okay, no one will ask you the proof. Of course in JEE, so no one will ask you the proof. But anywhere also they will not ask you the proof. Actually, we did not do it in the previous because I kept it for this question only. I'll tell you in the like in the question only, so that you will be able to analyze what is happening and how we are using the concept. So now question is, if A is a 3 cross 3 matrix whose elements are from -1, 0 and 3. Now A is a 3 cross 3 matrix. Matrix A is nothing but Aij 3 cross 3 matrix, where the elements will be only either -1, 0 or 1. These three kind of elements can be there, or these three numbers can be there. So what we'll do now? Now what we'll do? One more condition they have given, trace of AA transpose should be 3. Now see. 3 cross 3 matrix means what? Three cross 3 matrix means what? Total it will be having 9 elements. Total it will be having 9 elements. Now trace means what? And AA transpose is also 9 elements will come. Now trace means what? Only diagonal elements we are talking of. That means one element here, one element here, and one element here. That means only 3 elements we are talking about in the trace case. So in trace of AA transpose, which is nothing but Aij's whole square, where sigmas are already there. Sigmas are already there. Now this number should come out to be 3. This number, this number, this number. Now no need to keep it 0. Okay. The 0 will not make any sense, no. So what I am going to do is, first though I am going to write either, though I'll take matrix 1, oh sorry, element 1, or it can be -1. It can be 1 or it can be -1. So now see, first out of 9 positions, I am selecting 3 positions. Which 3 positions? These 3 positions. Okay. Now 9C3 will calculate what it will come out to be. Now suppose these 3 positions are selected. 1, 2 and the third position is selected. Now for the first position, how many options are there? Two options are there, either 1 or either -1, because anyhow -1 whole square will also come out to be 1 only. That's why I'm taking. For second position also, for this also two options, either 1 or -1. For this also two options, for this also two options. So 2 options into 2 options. So I'll simplify this now. 9 factorial. I hope you people know. So 6 factorial and 3 factorial, and this is nothing but 2 cube. 2 cube is nothing but 8. So simplify this now. 9, 8, 7 into 6 factorial will get cancel over here. 3 into 2 into 1. So 6 factorial cancel. 8 into 8. Oh, sorry, into 8 as it is. So 3 3s are, 2 4s are. So what it is coming? 12 7s are 84. 84 into 8. So if I'll simplify, 672. I hope I'm clear to everyone. 672, which option? C option is getting match. Only this much. Just that, those things which I explained you in the beginning, that is nothing but the property. The property is AA transpose if I'll multiply A and its transpose if I'll multiply, the trace is nothing but squares, sum of the squares of the AIJs. Alright, so this is just the concept which I have used here. This is the concept, and then this concept when I used, proof is only this much. Quickly we'll do. So trace is nothing but squares. Squares should come out to be 3. 3, how it will come? All has to be 1. 1 square plus 1 square plus 1 square. Okay, because either 1 is there or a -1 is there. 1 is there or -1 is there. 1 is there or -1 is there. 1 square is also 1, -1 square is also 1. 1 square is also 1, -1 square is also 1. 1 square is also 1, -1 square is also 1. So 0 cannot be there. No. If suppose this kind of matrix is there. Suppose 1, -1 and 0. And remaining elements are whatever. So 1 square is 1, -1 square is also 1, 1 plus 1 is 2, but which is not matching 3. So we want 3. That means it has to be either 1 or it has to be -1. Okay, so that's why I did. So this case was not possible. So that's why we take only 2 options. Either for the 3 positions which I have selected, out of 9 positions, I am talking about these 3 positions. These 3 positions can be filled in 2 ways. 2 ways, 2 ways and 2 ways. So it will be 2 raised to power 3, which is nothing but whatever the options raised to power number of places. This you must have already done in your permutations and combinations. So when we'll simplify, we'll get this answer. Quickly see and then we'll proceed. Again, I'll explain you the meaning of transpose once more, because after this I'm going to do one more question and then I'll proceed to another kind of matrices are there, that is symmetric matrix and skew symmetric matrix. So in that I'll be needing again transpose concept, so that's why I'll do that. First quickly just have a look and then we'll proceed. So I'm moving. Now another concept, same concept which we have already discussed, but I'm taking it once more. Transpose of any matrix, of a matrix A. Suppose A is any matrix. Transpose is nothing but I am changing row into the respective column. That's it. This is the only definition. So transpose, suppose one matrix is there, 1, 2, 3, minus 3, 1, 7, 3, 6, 8. Suppose this is the matrix. Okay. So transpose, if I'll talk about transpose, as I said, I can mark it as A dash also, or I can write A raised to T also. So transpose is nothing but first row will become first column, second row will become to second column, third row will become third column. Respective columns it will be changing. Now see what is happening here. Diagonal elements of course remain same only, of course. Okay. Now one kind of, first look at this quickly, then I'll proceed to skew symmetric and symmetric matrix. Now the another type of two matrices I am doing now. First is symmetric matrix. Symmetric matrix. Symmetric matrix is nothing but when A is equals to A transpose, then that matrix is nothing but symmetric matrix. Okay, one condition is there that all Aij's will be equal to Aj's for all I and j. Now what does it mean? That means, suppose if I'm talking about 3 cross 3 matrix, A1 1, that means I also 1, J also 1. So J is 1, of course. Now suppose if I'm talking about 1 2, it will be equal to A2 1, 1 3, it has to be equal to A3 1. Okay, jumbling of the J and I's, and it will go on so on. Any for A2 3 will also be equals to A3 2. Okay, so this is the definition. If any matrix and its transpose, they both are same, then those two matrices, then that matrix is nothing but symmetric matrix only. So I'm taking any matrix. Suppose if I'm taking A, B, C, H, H, G, G, and F, F. Suppose this matrix I'm taking. What will be its transpose? Now first row will become first column. First column will become what? This will be first A, H, G. Now second row will become second column, H, B, F. Now third row will become third column. See, A and A transpose is nothing but same only. AHG, AHG, HBF, HBF, GFC, GFC. So A is nothing but A transpose. So this kind of matrix is nothing but symmetric matrix. Quickly have a glance, then we'll proceed to the next matrix, that is skew symmetric matrix. And one your NCERT question is also there, like a few years back, I mean before COVID only, I would say, that question was board's ka favorite question only, that every matrix can be written as a sum of symmetric plus skew symmetric. That was the board's ka favorite question every time. But now though things have changed. So one is symmetric matrix. Symmetric matrix means A is equals to A transpose. Now coming to the skew symmetric matrix. Symmetry you have already done in your previous junior classes also you have already done. Now symmetry means what? Exactly the same shape, na, kind of. Just to relate it with that. This symmetry and that symmetry is of course different. I'm not comparing, but just to remember the way. That's what I said. I want to say like that. All right, now come to skew symmetric. Skew symmetric matrix. Skew symmetric is nothing but any matrix, suppose A is there, when it is equals to negative of its transpose, or you can say when transpose is there, it is equals to negative of the original matrix. Anyways, you guys can write A transpose equals to minus of A. So I'm taking in this way only. A transpose should be equals to minus of A. Because we have to see with the transpose, no? So that's why I'm taking this. I have removed that part. So one condition will come out to be here is Aij is equals to negative of Aj's. Negative of Aj's. Because of this sign, no? Negative of Aj's. Now take it on the left side. Take it on the left side, and for all I equals to j, I'm saying. So what it will become? Twice of AAI equals to 0. This implies AAI is equals to 0. That means A11 will be 0, A22 will be 0, A33 will be 0, A44 will be 0, A55 will be 0. That means all the diagonal elements will be 0. There is a way to see whether that is a skew symmetric matrix or not. That means diagonal elements will come out to be 0. Okay, when we'll do a determinant, no, that time also we'll see this once more. So what it will be? Skew symmetric matrix example, if I'll take, suppose any matrix, if I'm taking as I said, diagonal elements will come out to be 0. So it will be x, y, z, suppose. It will be minus x minus y. It will be minus z. Alright. Now suppose this is A matrix. See, it's A transpose. A transpose is nothing but what? First row has become first column. Second row will become second column. Third row will become third column. Now take minus sign from here. Minus sign, when you will take common, it will become this x0, sorry, this will become minus x. This will become minus y, minus z, and 0. This is nothing but original matrix only, minus of A it is coming. Okay. I hope I'm clear till here to everyone. We'll do the questions. So many things we have to do. Just this is the beginning. So we'll do. So many questions we'll do on this basis. As I said, every square matrix can be written as a sum of symmetric plus skew symmetric. Suppose any matrix is given A, this can be written as P plus Q, where P is symmetric and Q is skew symmetric. Now how it will happen, that I'll tell you. Just one property I'm using, it will be there in your NCRTs. Suppose any matrix is there, P plus Q. Okay, I can write A as what? 1 by 2 of twice of A. Twice of A I can write it as what? A plus A. Okay. This A I can write it as what? A plus A transpose. What I have done here is I have added and subtracted AA transpose. Okay, so I am taking this half of A plus A transpose plus half of A minus A transpose. Alright, when you will see, particular question we'll take, this will come out to be the symmetric matrix A plus A transpose, and this will come out to be skew symmetric matrix. How we can do is just take it with transpose. Transpose will become what? C. This should be equal to its transpose, no? So what I'm going to do is A plus A transpose, take its transpose. What it will come? A transpose, A transpose, transpose. Transpose is nothing but original matrix only. See, started from something, transpose came out to be that thing only. So it is symmetric. Similarly, if I'll take for this, A minus A transpose, take its transpose. What it will come? A transpose minus of A, I can write it as what? Minus I can take common. So it is nothing but what? Suppose Q dash is nothing but minus of Q, na? So this is the definition of skew symmetric. This is skew and this is symmetric. So this is just I am telling you the one property is there, that every square matrix, one condition is there, this has to be the square matrix. Every square matrix can be written as a sum of symmetric and skew symmetric. And no one will ask you the proof. Just those who want to go into depth, they can otherwise see. All right. If A is a square matrix, A plus A transpose, A transpose, A transpose A are the symmetric matrix. These all properties are there, already mentioned in your books. All right. Now, 4 types of special matrices are there. Special matrices we say. First is nilpotent, then is idempotent, then is involuntary, and then is orthogonal. Okay, now I'll tell you the definition of nilpotent. Nilpotent matrix. Now what does it mean? For any a raised to power n, for any, of course, natural number I am talking about, a square, a cube, a raised to power 4, for any n, if it has started coming out to be null matrix, and before it was not a null matrix, the main condition is A is not a null matrix right now I'm talking about. A is any square matrix. If I am taking its nth odd power, okay, nth times multiplication if I am taking, and if it is coming out to be 0, and A raised to power n minus 1 was not 0. The main condition is its previous was not a null matrix, but consequently it came out to be 0, or subsequently it is, if it is coming out to be 0 now, so this n is known as the index of nilpotency. Index, this is the index from where it has started coming out to be the null matrix. Okay, n is the index of nilpotency. N is the index of nilpotency. Next matrix is nothing but idempotent. Idempotent. Idempotent matrix is when A square is nothing but the original matrix only. A square is equals to A. Just take the example identity matrix. 1 0 0 1. When you will do it square, square means identity square is nothing but identity only. So that's what I said. Any matrix, it's square if it is coming out to be the original matrix only. Okay. So this is the best example, easiest example. Now involuntary matrix. Involuntary matrix. When A square is nothing but equals to identity. A square is equals to identity, not the original matrix, but the identity matrix. Difference between these two is idempotent original, square is coming out to be original, and involuntary, square is coming out to be identity. So the when we'll do the determinant, I'll tell you one more thing. Determinant will be of this kind of matrices is nothing but 1 or minus 1. Then comes your orthogonal. Orthogonality you must have done in some of the chapters. So it is not exactly that, but 90. Okay. So for orthogonal is, condition is A into A transpose should be equals to identity, or A transpose into A should come out to be the identity matrix. If this kind of things are happening, that means A and its transpose if I am multiplying, or commutatively, or A transpose if I am multiplying with A, if it is coming out to be identity matrix, that means original matrix. That means original matrix is A. A is an orthogonal matrix. So these are the things. See, these concepts, he will not ask you what is orthogonal matrix and you will tell A transpose equals to I. Everyone will be the IIT, and then of course these things will be, they will ask in some question, and then you have to use its properties. That's what material, whenever you people are attending the class, no, just open the material side by side. So one question I am taking now, and then you have to see which kind of matrix it is coming, that I'll tell you how. One question I'm taking now on the basis of this. So the question is, matrix A is given to us as 1 to 2. Question, matrix is given to us as 1 by 3 of 1 to 2. Next elements are 2 1 minus 2. And third row is given to us as minus 2 2 minus 1. So now options which are given to us as orthogonal, involuntary, idempotent and nilpotent, of course it is given. So what you will do, for other options you will check for A square. Check it for A square. Suppose if I am doing A square is nothing but what? A into A, multiply, that I am keeping outside right now, or this will become A into A, it will become 1 by 9, that I am not taking right now. Just we have to see what it is coming, or you can write it also, no issues. first 1 by 3 into 1 by 3 is nothing but 1 by 9 only. Okay. So now 1 into, if I have to multiply this with this itself only, 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1. Either the a square should come out to be equal to a, or it should come out to be equal to identity, or it should come out to be the null matrix. Then though I'll have the other three options. If it is nothing is coming, then we'll go for the ortho. Okay, so this is the way to how we'll proceed to the question. So multiply 1 into 1, 1, 2 2s are 4, 2 minus 2 is minus 4. So what else? 1, 2 plus 2 plus 4. Okay, and it will come out to be 2 minus 4 minus 2. All right, then it will come out to be 2 plus 2 plus 4, 4 plus 1 minus 4, 4 minus 2 plus 2. Okay, next is minus 2 plus 4 plus 2. First I multiplied first row with first column, second column, third column. These three elements came. Okay, now I am multiplying third row with first column. Now I multiply with second column, minus 4 plus 2 minus 2. 2 to the minus 4 minus 4 plus 1. So okay, we'll see now. This will come out to be 1. This will come out to be 6 and 8. It is not coming out to be the original A matrix. It is not either equals to original matrix A, not equals to identity also, not null matrix also. Nothing it is coming. Okay, so we have ruled out the three possibilities, that is involutory, idempotent and nilpotent. Those three options we have cancelled. Now A into A transpose, if I'll do transpose, shall I do it here only? Okay, A transpose, if we'll find 1 by 3 as it is, first row will become first column, second row will become second column, third row will become third column. Now multiply it with A. Okay, A transpose I am finding now. 1 by 3 into 1 by 3 is 1 by 9. 1 2 2, 2 1 minus 2, minus 2 2 1. Oh, minus 2 minus 1 it is. So A transpose is 1 2 minus 2, 2 1 2, 2 minus 2 minus 1. See, few people want me to skip few steps. Few people want the full explanation. So I am doing it in full explanation. If you want to skip the step, you can skip the step, no? Okay, if you are comfortable with particular step, skip the step and proceed, and side by side you can solve, no? Because what happens is everyone is having their different level, I would say. When they will understand more, that we can't judge. So that's why. And we should not judge also. That's okay if someone is learning fast, if someone is learning slow, no issues. Learning is happening, that's okay. So now first row will be multiplied with first column. It will come out to be 1 plus 4 plus 4. Then first row will be the second column, 2 plus 2 minus 4. Then I am multiplying with third column, minus 2 plus 4 minus 2. Then second row I am multiplying with 4 plus 1. No. If second row I am multiplying with first column. So what it will become? 2 plus 2 minus 4. 4 plus 1 plus 4. And this will come out to be minus 4 plus 2 plus 2. This will come out to be third row. I am multiplying with first column now. Minus 2 plus 4 minus 2. The third row, second column, minus 4 plus 2 plus 2. Then plus 4, 4 and plus 1. So every time you have to do multiplication like this only. When you will see, it will come out to be 9. It will come out to be 0, 0, 0, 9, 0, 0, 0, 9. So I'm writing it here only so that I don't have to turn the page for you people only. 0, 9, 0, 0, 0, 9. Now this 9 will be multiplied, or I would say 1 by 9 will be multiplied, or 9 will be divided. So what it will come out to be? 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, which is nothing but identity matrix. And if A transpose is coming out to be identity matrix, that is nothing but a orthogonal matrix. Yes or no? So what multiplication, just I'm telling you once more I'm telling you. See, first row will be multiplied with first column. So we will get this element. First row will be multiplied with second column. We'll get this element. This is first row, first column, first row, second column, first row, third column. Okay. See at the wordings, no? I mean, hear the wording. First row, first column. First row, second column. Okay. Correspondingly, they'll multiply and then they will getting added. So I hope this part is clear to everyone. Now one more question I'm taking. Involutory matrix means A square is identity. Okay, then we have to prove that I minus A into I plus A is nothing but null matrix, zero matrix. That I'll prove now. Do this question quickly and then I'll proceed. Next question. If A is a square matrix, okay. If A is, for any square matrix A, I'll change the question, wordings I'll change. Show that any square matrix A is involutory if and only if I minus A into I plus A is null matrix. Involutory means A square is identity. Now start with this, try to do it, then I'll do. If and only if means if this condition is there, this you have to prove. If this condition is there, this you have to prove. Vice versa case. Okay. If one condition is there, second you have to prove. If second is given, first you have to prove. So if and only if means this. All right. I hope you have started. Let, I'm starting. Let A is involutory. involutory matrix, then what will happen? A square is identity. Multiply these two matrices, what it will become? I into I is identity square, A into I is A into I, plus identity into A minus of A into A is A square. Okay, this we have to prove it equals to 0. Now I square is identity only. AI is also, as I told you, the identity matrix properties. Any matrix multiplied with identity matrix will come out to be the original matrix. This will also come out to be the original matrix. A square is nothing but identity, which is already given to us. So identity minus identity cancel, A and A minus of A. All when we will cancel, it will come out to be the null matrix. Second part. Now, if I minus A into I plus A is already null, now we have to prove whether it is involutory or not. So, okay. I into I square into AI plus IA minus A into A is A square, which is null matrix. This is identity only, this is A only, this is plus A only, and minus of A square as it is. This and this will get cancelled, like not cancelled, when it will, when you will add the original matrix with its negatives, you will get null matrix only. So remove it. A square is minus here, on the right side it will become plus with all the elements. So A square is equals to I. This implies A square is equals to identity, which is nothing but A is involutory matrix. Hence proved. So these kind of things we have to do: orthogonal, nilpotent, idempotent, and involutory. Okay, we'll do more things, but time is over right now. Okay, so bye guys. I hope